Creating Two-Sided PCBs in TINA, Part 2, TINA PCB Design Flow. In this tutorial, we will demonstrate the PCB design for the circuit we prepared in our previous video, Creating Two-Sided PCBs in TINA, Part 1, Preparing Schematics for PCB Design. Step 1. Placement of Components. Start TINA and open the circuit prepared in the previous video. The circuit is also available in the latest version of TINA as adc.tsc in the examples /PCB/ADC folder. Click the PCB Design icon. The PCB Design dialog appears. Note that the Auto Placement checkbox is set. Press the OK button. The PCB Designer appears with automatically placed parts on the board. However, the automatic placement is never perfect. Let's reposition the parts according to our requirements. Click the Select or Move Components and Tracks button. Then click on U1 and drag aside. Next, select the connectors. As they turn white, rotate them clockwise. Drag them close to the edge of the board. Now position the remaining parts according to this picture. Note that some of the parts should be rotated. Finally, change the size of the board. Click the Draw Modify Shapes icon. Next, double-click on the workspace. In the Shape Properties window, change the rectangle height into 1500 mm. Then click OK. Step 2. Preparation for routing. Now we check the design parameters before routing. Click Options. System Settings. The units are in mils, which were defined in TINA Schematic Editor under View Options. Click OK to close the System Settings window. Click Options. Layer Settings. We designed double-sided board with the components on the top. Copper routing will be applied on the top and bottom sides too. Close the Layer Editor window. Next, click Options. Auto Router Settings. We will use both manual and automatic routing for our circuit. Here, we can give direction preferences on a scale of 1 to 9 for auto routing. For now, leave them on default. Close the Auto Router Settings window. Next, click Options. Design Parameters. Now set Pad to Pad value to 6. This assures that our Sun 12 package will not violate the design rules. Click OK. Step 3. Routing the design. The PCB Editor offers several modes to assist manual and automatic routing. Click the Mode 2 icon button on the toolbar. Then click to the connection points at the ends of the rubber line. Manual routing is practical for small boards, but now we shall use the Auto Router. Click Tools, Auto Route Board. After the auto routing, we connect manually the unconnected nets, then revise connections and clean up design. Filling both sides with copper pour, we will create a ground plane and reduce the amount of etching liquid. Click the copper pour area icon. Then, by holding down the left mouse button, select the area you want to fill. Release the selection by clicking the left mouse button at the end point. We can assign the GND net to pour areas. click the Draw Modify Shapes icon. Next, double-click the copper shape, and in the Assigned Net field of the Shape Properties window, select GND, then click OK. To avoid the board edge, we set Board to Copper Pour to 40 mils. Click Options. Design Parameters. Enter 40 in the Board to Copper Pour field. Then click OK. Step 4. Final Touches. Texts and 3D View. Now we arrange component name texts on silkscreen and add some additional ones to identify the pins of the connectors. We will move the U1 label, which belongs to the silkscreen layer. Select Silkscreen Top Layer. Next, click the Select or Move Components and Tracks button. Click the U1 label, then drag it to the right place. You can rotate it while it is selected by using the Rotate Right or Rotate Left icons. Finally, let's see and test our design in a lifelike photorealistic 3D view. To generate the 3D model, press the 3D View button on the toolbar. The lifelike 3D model of the circuit appears. You can rotate the model by holding down the left mouse button while moving the mouse or using the arrows on the keyboard. You can zoom in or zoom out by holding down the right mouse button while moving the mouse. Step 5. Design Rule Check, DRC, and Making Layer Images. The DRC process is a very important step at the end of the design before we generate data files to the PCB manufacturer. Click the Tools menu, select DRC, and then Run DRC. As there is no error message, just click OK. If there is no DRC message, then it is time to have our board made. Typically, this means creating Gerber format files for a professional manufacturer. Click File menu. Select Export Gerber File. Click Save. It is also very important to check Gerber files once the design is completed. Note that many free viewers are available, like ViewMate, GC Preview, and more. Step 6. Live 3D View. Let's run transient analysis with 3D View. Press the TR button to run transient analysis. You can change the voltage input. Double-click the VIN and enter 1.8 in the voltage field of the VIN voltage source window. Then click OK. For more tutorials, visit our website at www.tina.com/english/tina/video_tutorials. Download the demo version of Tina Design Suite, and you will get an immediate 20% discount from the offline version of Tina. Free license for your second computer, laptop, etc. 1 year free access to TINACloud, the cloud-based, multi-language, installation-free online version of Tina, running in your browser anywhere in the world.